Hi everyone, going to be taking a quick look at this colour OLED screen today. I think we saw this in the last mailbag video. I actually bought two of them, got another one here. So as you can see, I've actually built on the previous project and hooked this up to this temperature sensor, and I've got the temperature display reading out. So I'll talk you through how I put this together. So this screen here is easier if I look on the camera actually. So it says just here 0.9596 times 640. Not entirely sure what all of that means. I don't know if it's 96 pixels by 640. That doesn't sound right. Not too sure. I did a little bit of Googling on this, and it turns out that it is an SSD1331 chip or controller or display driver, whatever the right terminology is. And it turns out that there is an Adafruit library for that, so this should be easy to use. We'll find out. I ordered two of these OLED screens. I should have the other one here. I believe one of them is full colour and one of them is like a monochrome, I think, probably blue and white, I'm not too sure. They are quite possibly different driver chips, I don't know. And I believe that this one that we're going to look at today has an SPI interface that we need to interface with, and this one here we'll look at another day uses the I2C interface. You can see it's got less connections on it. So how do we connect this up? So normally on an SPI interface we would have a master in, slave out, and a master out, slave in, sometimes known as MISO and MOSI. There would also be a clock, and there's a line called SS, which I believe stands for slave select. I'm not too familiar with the SPI interface, I don't use it that often. Now this board originally had me fooled into thinking it was an I2C board, because normally on an I2C interface you would have SCL and SDA, and we do have here those two lines, SCL and SDA, in the middle there. Just about make them out. So I originally thought it was I2C, but it turns out it's not. It turns out it's SPI. But what makes it slightly odd, and I think this is quite common, is there's a couple of extra control lines. Now, I believe the clock is normally called SCK, but on this board it's labelled up as SCL, but it just means serial clock. And that the line on here that's marked as SDA is serial data. Again, it's I2C terminology, but I believe that is actually master out, slave in. So we're sending data out of the master, which will be the Arduino Uno in our case, and into the slave, which is this device. So it's master out, slave in. Now we don't send any data in the opposite direction, so we don't need the MISO line, and I don't believe there is a connection for that on here anyway. And the other line we normally have on SPI interfaces is normally called SS, slave select, and on this board it's actually called CS. It's the one right at this end, and that generally stands for chip select, which does make sense when you think about it, because from the Arduino's point of view that this is the slave, and from this board's point of view chip select is just enabling this device, so that kind of makes sense. The only other connections that we've got, VCC and ground, are going to be pretty obvious, and then we get this RES line, which I believe stands for reset. And then there's this extra line here called DC. Now that normally stands for data/command. So it tells it whether we're sending it data to it or whether we're sending it some kind of special command for it to carry out. We don't need to get too bothered about all of these technical details because the Adafruit library will handle all of that for us. All we need to do is just figure out how do we connect this up to an Arduino Uno. So let's bring the Uno in and we'll have a look at doing that. So here's our Arduino Uno. Going to be using another one of these little breadboards that have been appearing recently in the videos, and this time we're using the blue one. So I'll start by just plugging this in here. We might as well plug it straight in the middle. Now I'm going to go for the bottom row of connections on this top section. Just going to slap it in there, and that'll allow us access to these additional connections here. And I think the whole thing is a bit twisted there. It's not soldered on very straight, but it doesn't matter too much. It'll do the job for us. So let's start with the easy connections, and I'm going to apologise for my choice of wire colours here. I'm just using what I've got. For VCC and ground I'd like to use red and black, but I don't have any of those colours. So I'm going to go with pretty unconventional. I'm going to go with orange for my VCC. Now I believe we need to connect this to the 3.3 volt on the Arduino. Power this board from 3.3 volts. So we'll take that to VCC. That'll be this one here. And then we'll go with the ground, unconventional colour of green. I'll put that in there. And this is our ground here. Now on the Arduino Uno, the clock pin is pin 13. So I'm going to have to stretch this across the board here. This is pin 13 over here. And yes, the next connection is SCL. It's a little small to see, but that is the clock line is next. Then we're going to skip the MISO connection and we're going to go straight to the MOSI connection. That is pin 11 on the Arduino Uno. So that's pin 11, and that will be our SDA on this board. But like I said, that's normally called MOSI. This is getting fiddly. I think that's right. A bit dark. I never know whether to put the light on or not. We'll try the light. Might be a little bright. The next line is the reset line. I'll leave that for the moment. And we've got the reset in data/command, and then the last one is chip select. Now we know where that is because on the Arduino Uno that will be pin 10. So that's going to be that one there. That's our last connection here. Which means we just got the reset line and the data/command. Now essentially we're free to use whatever pins we want because we can control this in our sketch, because I have looked ahead a little bit. So we're going to go with, let me check here, what did we have? Reset on pin 9. So there's pin 9. Let's reset. And data command is going to be pin 8. That one there. I'll squeeze this in here. It's all a bit tight, but they are all in there. So let's see if we can find these Adafruit libraries to see if we can get this thing working. So I've switched my Arduino IDE over to a MacBook. I did that for a few reasons. The main reason was to try and get better screen recordings. It's a little bit better quality on the Mac. But the Windows laptop, the fan was quite noisy, so that made recording a little bit difficult, and it was also very slow. So hopefully this setup will be a little bit better. But as this is a new setup, I haven't got any of the libraries that we require. So let's see if we can install them. If we go to Tools and Manage Libraries, and then we want to search for SSD1331, and I believe this is what we need, so we'll install that. It says that it needs Adafruit GFX, which I didn't know. I'm going to say install all. Okay. It said that it needed this, but it doesn't look installed. I'm sure that's what we need, and it's not installed, but let's just see what happens. So we're going to File, Examples. We should have, see the GFX library is there, so I think it is installed. This is the 1331 OLED driver library. I'm just going to have a look at these demos here. I think we'll look at this one first. GFX demo for multiple backends. Let's just upload it. Let me just check the pin numbers here. So yeah, these pins are a little bit different. I think I had them set to 10, 9 and 8. If you look here, it says option 1, use any pins but a little slower, and this is the software SPI, but that's commented out. And then option 2, must use the hardware SPI pins, so you're stuck with pins 13 and 11 if you want to do this option. And pin 10 must be an output. Pin 10 being the chip select, I believe. Not quite sure why it mentions that. Yeah, this is the hardware SPI, so you can see instead of passing in all of the 5 pins, you just pass in ampersand SPI and then just the chip select data command and reset. So that's the way we're doing it, so that should be fine. So let's upload that. The other thing with a Mac is I'm finding this is much faster. Uploading. And done. Now, I just want to mention here, just try and bring this up so it's a little closer for you, that flickering that you can see, it's not just the video camera recording, I can see the same flickering on the screen, but it's not quite as bad when you're looking at it directly with your eyes, but it is flickering a lot. So I just guess that's just got something to do with the speed that it updates the screen. Again, it is flickering here again, but not quite as bad as what you can see on the video, but it is flickering. I've never actually watched this demo right through. Okay, let's take a look at the other one. Again, if we go to File, Examples, and I think this one is called Test. I believe this one has the pins set up as we want them. So let's upload that. Now this time there's no flickering on the screen, so any flickering that you are seeing is just the video camera. So not quite sure what the difference is between the two demos, but they're just giving you some examples really of what the screen is capable of. I think what I'm going to do next is I'm going to bring in my temperature sensor from the previous video that we were looking at. It's the TMP36 temperature sensor. I've still got the LED and resistor on this board. We're not going to use those, but I'll just leave them there. And the nice thing about these little breadboards is that you can snap them together. So all we need for this sensor is 5 volts ground and then the analog line. So the 5 volts is in here. That. The ground, I'm just going to piggyback off the ground that we've already got over here, and we'll use A5 because that's what we were using before. Now I do have a sketch ready here. So basically we're including the Adafruit GFX library and the Adafruit SSD1331 library. Obviously we're going to need that. That's the hardware SPI library, I believe. I've got some colours defined here. I think I probably stole these from one of the demos we just looked at. Then we've basically got our pin configuration here, chip select, reset and data command. And that's just us instantiating the SSD1331 object. It's going to be called display. Sensor pin here is my temperature sensor pin, A5. I've got a float for the current temperature. In the setup function, I have got some serial stuff in here, but I'm not using it, so we could ignore this. The main thing is we're doing a display.begin. That's just to sort of initialize that display object. Then we're doing a fill screen black, so we just clear the screen, make everything black. Now I've created this display text function. It's my own function. We'll look at it in a second further down. But basically I can pass in X and Y coordinates, the font size, the text I want to display, and the color from one of those definitions above. So I'm just displaying the word temperature in yellow. And then here we're using one of the Adafruit GFX library commands or functions, whatever you want to call it, called Drawline. I believe this is the X and Y start position and the X and Y end position. So as the Y is 40 in both, we're going to get a horizontal line. I believe it's 96 pixels across the screen. So it should go all the way across and it's going to be in yellow. Then we've got the main loop. I've got this float here called Getdexc, and we'll look at this function again in a minute, called average temp. So we just call that to get our temperature in degrees C. What I'm doing here with this if statement is just saying that if the temperature has changed. So if Getdexc does not equal the current temp, then it's changed. So we need to update the display. So if that is the case, I'm just setting current temp to be the Getdexc. So we're just remembering it for the next time around the loop. And then I'm calling update display. And then I have got a 2-second delay in here, so we don't update too frequently. So we'll only update if the temperature has changed, and will only do it at a maximum of 2 times per second. No, that's not true, is it? Once every 2 seconds. That's the right way of saying it. So this is the update display method. So I've got a string called temp text. I wasn't quite sure how to work with strings with C++ because I'm not really a C++ programmer. I'm not too familiar with the language, but hopefully I know enough to get by. So I've got a string called temp text, and we're basically taking in that float value and converting it to a string. Then I'm calling concat on that string and concatenating the character 247, that's the little degrees symbol, and then I'm concating the character C. So we'll have the temperature and then the degrees C. Then I'm calling display.fillRect. Now what I tried to do here, I tried to optimize it a little bit. I'm using this to blank out part of the screen where we're going to draw this text. And I'm trying to make the fill rect, not the whole screen. I'm not going to blank out the whole screen. I'm just going to blank out the area where we want to update this text. So it's 0,20. I believe that's the start X and Y coordinates, and then the end X and Y coordinates. And it's going to be in black because we're going to blank out that part of the screen. And then I'm going to display text at 0,20, so the same position as the top left of my rectangle. So we'll display text in font size 2. We're going to use the text that we just built up, and it's going to be in cyan. Now this is actually my display text function down here that we're calling. I've called this twice, once in the setup and once in that update display. So it's just called display text. It takes the X and Y coordinates, the size, which is the size of the font, the actual text that you want to display, and then the color. And basically all that does, it sets the cursor to the X and Y coordinates, sets the text color to the color that we require, sets the text size to the font size we specified, and then displays the text. So it just wraps up all of these functions and makes it so that I can draw text in any color, any position, any size, just with one single command. Just makes drawing text a little easier. I'm not sure if there's something already built into the GFX library. You would have thought so, but maybe I'm reinventing the wheel with that. Finally, we've got this average temp function. This is, if you watched the previous video I did on the TMP sensor, the TMP36 sensor, some of this might already look familiar, but what I'm doing here, I'm calling this average temp. What I'm doing is taking 5 readings and then taking the average. This is a technique I tried to sort of try and stabilize the temperature a bit so you didn't get too many fluctuations. I don't think it made much difference, to be honest, but this is what I'm doing. I've got a sum, which we're just initializing to 0. Then we've got a loop here. We're going to go around 5 times, and then we're just going to get the degree C and add that to the sum. So we're just getting 5 readings and adding them all together. And then finally, we're just going to divide by 5. So that's just taking the average of the 5 readings and then returning the result. Then we've got the actual Getdexc function. This is the function you probably saw in the previous video. We're just taking a value from the analog read. So that will be our 10-bit ADC value. Got here a float called millivolts, which is the sensor value divided by 1023. Multiplied by the maximum voltage. So it's normally 5 volts, but I've measured it at 4.96. So we're using 4.96 to make it a bit more accurate. And then we multiply by 1000 because I'm calling this millivolts. So normally it'd be volts, but because we're multiplying by 1000, it becomes millivolts. I guess I could have just multiplied by 4960 rather than doing 4.96 times 1000. I am printing that out to the serial, but we're not looking at that. This is just to convert the millivolts into degrees C. There's a half a volt or 500 millivolt offset on this sensor, so we just negate the 500 millivolts to just sort of disregard our offset, and then we divide by 10 because it's 10 millivolts per degree C. So that gives us degrees C, which is what we're returning. So that's basically all the sketch is doing. So let's upload that and see what that does. And there you go, we've got a little temperature display. The word temperature at the top in yellow, and then the actual temperature and the degrees C in cyan, and I think the other yellow line was also printed in the setup function. So we should be able to just warm the sensor up and see the temperature increase. See there, it's going up. 24. Just calm down a little bit. Seems a little erratic. You can see sometimes the temperature's going down rather than up. So I've got my finger on it, I'm warming it up. I'm probably not going to get it much hotter than that. Take my finger off, it should cool down again. Yeah, so it's basically working. So that's a quick look at the SSD1331 full color OLED display. Hopefully you found that of some interest. If you enjoyed the video, please give me a thumbs up and please subscribe to the channel. I'm trying to build up the subscribers. We're getting very close to the 1,000 mark, so I'm just trying to have a real push on gaining a few more subscribers just to get us over that 1,000 subscriber line. So thanks for watching, and I'll see you next time.